In March 2012, a man named Lawrence Anthony died quietly at his home in Thula Thula Game Reserve, South Africa. He had spent over a decade rescuing and rehabilitating wild elephants, a herd that had been marked for culling in 1999, deemed too dangerous to live. Lawrence fought to keep them alive. He walked among them daily, learned their behavior, and earned their presence. When he died, nobody told the elephants. There was no signal, no sound, no human messenger sent into the bush. And yet, within 2 days of his death, two separate elephant herds, living miles apart deep in the reserve, began walking. They walked for over 12 hours through the South African bush and arrived at Lawrence's house. They stood outside for 2 days, then they left. They had not visited the house in over a year before that moment. Nobody has fully explained how they knew or why they came, but they did. And that is exactly the question this video is going to sit inside. Humans have been rescuing wild animals for as long as we've lived alongside them, pulling creatures from traps, cutting ropes from exhausted bodies, lifting animals from mud they couldn't escape alone. And every single time, the same question follows the rescue. Did it know what I was doing? Will it remember? Science has spent decades quietly building toward an answer. What it has found doesn't fit neatly into what most people expect, because the answer isn't simply yes or no. It's something more complicated and, in some ways, far more remarkable. To understand why some animals remember their rescuers, you first have to understand what being trapped does to a wild animal's body. The moment an animal loses the ability to move, its physiology enters a state with no real human equivalent. Stress hormones detonate through the bloodstream. Researchers measuring them in trapped deer found concentrations higher than in animals that had been shot by gunshot, higher than animals struck by vehicles. The heart doubles its rate, then doubles again. Every biological reserve the animal has gets redirected toward one single outcome. It is preparing to die. So when a human approaches a trapped animal, the animal doesn't register as a rescuer. It registers apex predators arriving at the worst possible moment. This is why the struggling intensifies the closer you get. The animal is spending its final energy on the only response its biology has ever rewarded. And then, in some of these encounters, something shifts. The body goes still. Not from exhaustion, something more deliberate than that. The animal turns not away from the human approaching it, but toward them. Researchers believe this comes down to a very specific mechanism. A predator closing in to kill moves fast, aggressive, in a direct line. That exact movement pattern is what the animal's alarm system has been to detect across millions of years of evolution. But a human trying to help moves completely differently, slowly, without sudden gestures, touching the trap, not the animal, producing no sounds that match anything in the known threat catalog. The brain searches its entire library of danger signatures and returns nothing. With no recognized pattern to respond to, the crisis response stalls. The animal waits. In Yellowstone, a research team located a wolf caught in a leg-hold trap. It lunged and snapped at every approach, exactly what the biology predicted. Every human step forward triggered another explosion of movement. One researcher stopped moving entirely and held steady eye contact with the animal. Not aggressive, not advancing, just present and watch. Here's why that matters. A predator closing in to kill does not hold steady eye contact. It watches movement, tracks the body, calculates angles. Sustained direct eye contact without accompanying aggression or forward movement sits completely outside the standard predator template. The alarm system, already searching for a pattern it recognizes, encountered something it was never built to classify. After several minutes, the wolf stopped lunging. It sat down. It held the eye contact back. When the trap was released, the wolf stood still for a long moment. It looked directly at the researcher. Then it turned and walked into the tree line. Scientists describe this as suspension of threat response. The alarm system doesn't switch off. It simply loses its anchor point. The expected sequence of predator behavior never arrives, and the crisis response has nothing to lock onto. But that only explains what happens during the rescue. It says nothing about what comes after. For a long time, scientists believed episodic memory, the ability to recall a specific event involving a specific individual across significant time, was a uniquely human capability. The assumption was that reliving a personal past required a level of self-awareness other animals simply didn't possess. Then the research began arriving, and it kept contradicting that assumption. In 2008, Professor John Marsliff at the University of Washington ran a landmark study on crows. His team wore specific masks while handling crows on campus, trapping them briefly for research, then releasing them. Months later, the same crows not only recognized the masked faces of the researcher, but scolded them from a distance, dove at them, and recruited other crows to do the same. 5 years later, the behavior was still active and had been passed to crows that were never present during the original encounter. These birds encoded a specific individual associated with a specific experience and held that association for years. Now apply that same mechanism to a rescue. Researchers at Emory University studying social bonding in mammals found that primates, elephants, and cetaceans form long-term memories through the same hippocampal pathway humans use for emotionally significant experiences. The hippocampus doesn't store events neutrally. It tags them by emotional weight. An experience that carried extreme fear followed by sudden relief involving a specific individual gets encoded differently than background information. It gets weighted, and weighted memories are the most stable across time. An animal that was dying and then experienced that dying stop because of a specific person doesn't just log the event as human. It records something much closer to a full experience. The feel, the hands, the smell, the exact moment everything changed. A man named Christian rescued a jaguar cub near a logging site in Brazil. She was found abandoned and malnourished, days from death. He raised her. Her name is Jiquitai. 4 years later, a video captured Christian standing waist deep in a river when Jiquitai, now a full-grown jaguar, swam directly toward him. She wrapped her paws around his shoulders and pressed her face against his, the way a domestic cat greets someone returning home after a long day. 4 years. A completely different body. A completely different life. She still came to him specifically. Christian has noted that Jikataya behaves differently with him than with any other caretaker at the sanctuary. She tolerates others. She moves toward Christian, and she has grown more gentle with him over time, not less. Wild animals don't become gentler toward things they are for simply using. They become gentler toward things they have decided to trust. There is a difference between those two things. And apparently animals know the difference too. Which brings us back to Thula Thula. Back to 2 elephant herds walking through the South African bush in the days after Lawrence Anthony died. Elephants have the most extensively documented long-term memory of any land animal. They recognize individual humans across decades. They return to the bones of family members who died years before and touch them with their trunks. The cognitive equipment to hold a specific individual across time, to carry the weight of a relationship, is not something elephants are missing. Lawrence Anthony spent over a decade walking among those herds, learning them, keeping them alive when the rest of the world had given up on them. When he died, they came. Whether what they felt in those 2 days standing outside his house is anything close to what we would call grief or gratitude, science cannot reach that far yet. The tools are getting better. The research is accumulating. But here is what the data does show. The brain structures that hold emotionally significant memories predate humans by tens of millions of years. The capacity to remember a turning point, a moment when everything was lost and then wasn't, is not something we invented. We share it with them. And sometimes, when the moment was significant enough, when the fear was deep enough and the relief was real enough, they find their way back to it, even when no one told them where to go.